Now generally when we want to transport fluid from one location to another location, then in that case we have a reservoir, and this reservoir is connected to a pipe. Then again the pipe is having some kind of arrangement, and then end of the pipe is again connected to some another reservoir or end user, right. So if we observe this phenomena, then we will find, though we have not studied the boundary layer, but even then it is important to find out that what is the meaning of entrance region, because whatever formula we are going to develop for finding out the head loss, that is applicable only for fully developed flow. It is not that for any length of the pipe we can find out the head loss. So we will try to understand the limitation of the formula which is being developed for finding out the head loss through a pipe. When fluid enters from one reservoir to pipe, in that case the boundary layer, or if we observe the velocity profile, this velocity profile is continuously changing, and it changes up to certain point, and after that it attains some velocity profile. Like at this section, what is the velocity profile? It is shown here with the help of this curve. At this point at the periphery the velocity is 0. As we go towards the center, velocity increases. As again we go towards the periphery, velocity decreases, and at the periphery velocity is 0. And after this, if this velocity profile remains constant, then that flow is termed as a fully developed flow, fully developed flow. But whenever the fluid changes the direction, the fully developed flow concept does not hold good, and again it has some kind of developing flow, and then again the velocity profile becomes constant, and then again we can use the formula for fully developed flow and we can find out the head loss, right. So this can be understood with the help of this diagram also. In this diagram we have a pipe in which fluid is entering. So everywhere velocity is same, it is u0, and as fluid comes in contact with the solid boundary, the velocity at the surface has to be 0 to satisfy no slip condition, and as we go enter in the pipe, the velocity is increased. So here velocity profile is different, here velocity profile is different, at this section is different, at this section it is different, right. Now onwards, if the velocity profile remains constant and which is equal to this, then the remaining portion can be analyzed with the help of fully developed flow formula which we are going to develop. So from this point to this point, the flow is termed as a entrance length flow, and whatever formula we are going to develop, that is not applicable for entrance length, and empirically we can find out what is the entrance length.